Today we will be looking at the interior and exterior angles of polygons. So in the activity that you completed before, you were asked to compare the number of triangles that you could create in a polygon with the sum of both the interior and exterior angles. Hopefully your findings look somewhat like mine, and there are a few trends I want to highlight. So if we let n be the number of sides, like such, then the number of triangles is always n minus 2. You can see that here. 3 minus 2 is 1, 4 minus 2 is 2, etc. Likewise, the sum of interior angles is always 180 times the number of triangles. So 180 times the number of triangles, which we know is actually 180 times n minus 2. And again, you can see that pattern by going back and forth between the columns. Finally, the last trend I want to highlight is that no matter how many interior triangles you were able to create, the sum of the exterior angles was always 360, so that was consistent. Now let's work through some examples. So the sum of the interior angles are given below. Determine the number of sides for each polygon. So the first thing I want to highlight is what we learned from the chart above, that the sum of interior angles is equal to 180 times n minus 2. Now using this formula, we can tackle these problems. So the sum of the interior angles is equal to 180 times n minus 2. We know our sum of interior angles is 540, so we can plug that in. And now we continue to solve by isolating for n. So the first thing we're going to do is get rid of the 180 and divide both sides by 180. And these cancel out, and we're left with 3 equals n minus 2. Now we're going to add 2 to both sides. These will cancel out, and we're left with 5 equals n. Therefore, this polygon is a pentagon because it has 5 sides. Now let's work on this example. We can do the exact same steps. So we'll start with our formula. Again, we know the sum of the interior angles is 1080 degrees, so we'll plug that in. And then we can divide both sides by 180, and that will get rid of those, and we're left with 6 equals n minus 2. Now we'll add 2 to both sides. Again, these will cancel out, and we're left with 8 equals the number of sides. Therefore, this is an octagon. The next example, we are asked to solve for the angles in each polygon and state the properties that we used. We're also asked to use SAP for sum of angles in a polygon when working with unknown angles. So the first thing that I notice is that we have the values of each of the interior angles. So again, I think we should use the sum of interior angles formula, which is 180 equals the number of sides minus 2. Now, to plug everything in, we can plug the sum of all these values in for Sn. So x plus 15 plus x plus 25 plus x plus 20 plus x minus 20 is equal to 180. And since we have 4 sides, we can plug 4 in for n minus 2. Now, let's solve a little further. So we can combine all our x's. So we have our grouping of like terms, and then we can combine all our numbers. So 15 plus 25 plus 20 minus 20. And we can simplify that to 2. Now we're left with 4x. And here we're left with 40. And on this side we have 360. Now, let's bring the 40 to the other side by subtracting 40 from both sides. And obviously these cancel out, and we're left with 4x equals 320. And now if we divide both sides by 4, we're left with x is equal to 80 degrees. So now, to figure out each of the individual angles, we just simply plug in 80 wherever we see x. And we also have an x plus 25, which gives us 80 plus 25, which equals 105 degrees. And we have an x minus 20, which equals 60 degrees. And finally, x plus 20, 100 degrees. Our final step is to state the properties that we used. So, the property that was used here was the sum of angles in a polygon. So we put SAP beside to tell our reader what property that we used. For our final example, we need to solve for x and y. So the first thing I'm going to use is our supplementary angle theorem to solve for y. So we know that these two angles need to total 180 degrees. So I know that 100 plus y has to equal 180 degrees by our supplementary angle theorem. Now I can move the 100 over to the other side by subtracting 100 from both sides. So I now know y is 80 degrees. Now to solve for our x's, we're going to use the same idea from the question above. And we're going to use the sum of interior angles of a polygon is equal to 180 times the number of sides minus 2. So now we can do y plus x plus 35 plus x plus 25 plus x minus 35 plus x minus 15 is all equal to 180 number of sides minus 2. So now let's combine all our like terms on the left side. So we can plug in 80 for y plus all the other numbers. And now we can add all our x's. And then this is equal to 180. Count the number of sides. We have 1, 2, 3, 4, 5 sides. And now we can add up all our values over here, and you'll see that we get 90 plus 4x equals 180 times 3. And we get 90 plus 4x equals 540. And finally, if we subtract 90 from both sides, these cancel out, and we're left with 4x equals 450. And then let's divide both sides by 4. And we're left with x equals 112.5 degrees. Now we go back over here, and we have to plug in the value for x to find the exact angle values. So x plus 35 equals 112 plus 5 equals 112.5 plus 35, which is equal to 147.5 degrees. We also have an x plus 25, which is equal to 112.5 plus 25, which is equal to 137.5 degrees. We also have an x minus 35, which gives us 112.5 minus 35, which is 77.5 degrees. then finally we have an x minus 15, which is 112.5 minus 15, which is equal to 97.5 degrees. And there you have all of the exact values of each of our interior angles of this polygon.